Hello and welcome back to this series of how to hook your test gear up to your stereo gear, back to your test gear stuff. In the first part of the series, we looked at how to hook up our amplifier, and we went through the configuration of all that. In today's video, we're going to do the same thing, except for we're going to do your cassette deck. Now, this does not necessarily have to be a cassette deck. This will work on your 8-track, your reel-to-reel, CD player, DVD player, mini disc player, anything of that nature. It'll work just fine, even with video such as VCR or DVD out. You could do this just the same for your audio. So in this video, we have a lot of test gear we're going to go through. So I'm probably going to go as fast as I plausibly can to try to keep this video down short. I suspect it will be lengthy just like the last one, but there's going to be a lot of meat, and just like in the last video, there's going to be an expectation that you know how to operate your audio gear as well as your test gear. I will try to guide you and give you some pointers along the way, if I can remember, to try to help you out to achieve and be successful in the goal at hand here. Just like last video, this video is going to be shot on shaky cam. Cannot do it on a static cam. I'm going to be all over the place. So with that, please accept my apologies for the shoddy videography that's going to happen throughout this, but I hope you could understand the reason why and all that good stuff. So without further ado, let's go ahead and get started. What you're going to need is whatever you have on hand to test. In this video, I'm going to test not all my test gear, but we're going to test a good chunk of my audio related or non-related gear that would work in doing this. So what you have on hand is what you have on hand, and you just got to learn how to work with what tools you got, plain and simple. As I stated in the last video, wires is going to be really something that you want to have a good premium of. But if you don't have good premium wires, again, just work with what you have and try to ramp up to something a little better later on. And the reason I focus on the wires more than anything is if you use subpar wires such as speaker wire, which will work, you're just looking at introduction of noise through the configuration, through the wires, trying to read on your frequency counter. It might not be stable. You might get some weird stuff happening on your O-scope. So you may not get a true reading or a close to accurate reading. It may be jumbled all over the place. So if you are using inferior wires, just understand and expect that, and whatever reading you get, try not to take it too close to heart, as once you get better wire, your results may change. So what all do we need? What all are we going to be using, I should say? Well, I got a vintage tape deck. I've done practically nothing to this. Well, I shouldn't say that. I partially serviced it a year ago. I cleaned the heads, demagnetized the bay, cleaned the bay, and I did calibrate the motor at that time. I did no cleaning, no relubrication, nothing like that. Still uses the same belt. This deck is from, oh gosh, well, let's find out. Okay, not seeing a date code on this one. I thought there was a date code. No date code. So it's from the 80s. I think it's from the mid 80s. So and it's been a good little deck. I've definitely enjoyed it. But that's neither here nor there. So that's the stance with the deck. You're going to need your O-scope, or we're going to use an O-scope, and really that's really what you want to use to do this. If nothing else, have an O-scope, but we'll look at maybe doing it other ways. We have a AC millivolt meter, so as long as you have a sensitive AC meter, you should be good. It would be awesome if you had a analog meter such as this, but this can also work with a digital meter. Just with your analog meter, you could really get down to the nitty-gritty and look at little tiny movements a lot better than you could with an O-scope. We're going to use a audio frequency generator. It don't have to be nothing this snazzy. You could use whatever you've got that can produce 20 to 20,000 hertz. Actually, all you really need is 1,000 hertz. But if you've got the full range, that's going to be spectacular. A frequency counter. Again, frequency counter don't have to go too high. 20,000 hertz is the highest you're going to go with audio. So cheesy frequency counter. It'd be great if your frequency counter is as close to accurate as possible. But if you're not doing lab grade testing, then close enough works for me. We have a wow and flutter meter. And then we have a audio spectrum analyzer. And then we've got a whole gobbledygook of wires, a spaghetti mess, connectors. We have a demagnetizer, alcohol, and cotton swabs. And this is to clean the head. Like I said, it's been about a year since I've done that one, and I have ran a lot of tape through it. Speaking of tapes, need a myriad of tapes. We have we have a test tape for recording onto, and then I've got two reference tapes. They're basically the same thing. And then I have a different kind of demagnetizer, and then a piano tape. And we'll talk about that when we get that far. You can run this through your amplifier, but really it's recommended that you only work with the tape deck only. By going through an amplifier, equalizer, or anything else like that, you have a greater possibility of not getting a truer reading and a greater possibility of anything else influencing your signal. So you want to strip away everything that you plausibly have and just work with the device only. Your test gear should be sensitive enough to read the signals, no issues. Now, as far as test gear is concerned, you should be able to also do this with software-based test gear, whether it's on your cell phone or on your computer. Just take great heed to the fact that you are shoving voltage into your computer sound card and into your cell phone. Unlike traditional test gear, those devices, your sound card, computer, and cell phone, is going to be very sensitive, and you're not going to be able to shove large amounts of voltage into it. And by doing so, you can damage your cell phone and computer or test card or anything in the in between the middle, in the whole string. So if you do so, you're doing that at your own risk, and you understand what's happening. Keep your voltage as low as minimal. Always start with everything down to a baseline, 0, and then work your way up if that's your environment. If you could also add attenuators in line, that'll help cut the voltage and hopefully protect what you have. Okay, with all that said, let's go ahead and get started. So what we're going to do is we're going to port in a 1000 hertz signal, and I've got it set to 1000 millivolt peak to peak, which is also 1 volt peak to peak. And so of course it's a mono device. We got it going into through a cable, and I got it shoved somewhere. Where do I got it? Wrong cable. Okay, so I've got this going into the stereo, so let's unplug the stereo. So for my cable, it's just like the last one. It's the same one we used in the first video. It's a BNC on one end, it's a RCA male phono on the other end. The cable is RG8U. I'm sorry, RG59U. RG59U. And then we're going to go into a Y connector, and this Y connector is a female on one side, and then it ports out to 2 males on that end. And we're doing that to plug into both channels. If you don't have one of those, it's okay. You'll just have to work with one channel at a time, and that's no big deal. Then we plug each one of those into your line input. From your line input, or from your line output, we have 2 cables, one for the left channel, one for the right channel, and I'm using RG316 coax cable, BNC connectors on both ends. However, on this one end, the tape deck end, I have a BNC to RCA adapter, and let's see, so that is going to be my right channel. So, plug it in. Do apologize for the camera work. Already talked about that. And then we got same identical cable for the other channel. And then we come over to our O-scope, and we plug it in. So left, right. So if you've got a 2-channel scope, this will be perfect, because then you'll be able to see both waveforms on your scope. If you only have one cable or just one input channel on your scope, then just, again, work with what you have. So we come over to the tape deck, and we need to make sure our record controls are down. We need to eject this, and this is where I need two hands. So what I need to do is I need to hit the record button, but at the same return, since I don't have a tape, well, actually, let me just put a tape in there. I got one. And that would make sense anyway, because we're work on this, whoops, wrong tape. So I got a test tape. I've got it already queued up. All right. So now I hit my pause, clear my counter, zero out my counter. I hit record. And then I make adjustments here on my left and right record controls, and I want it to hit right there. So I'll bring the other one up. Alright, and if you could see what it says here on the display, we're at the 0 dB mark, and so that's where you want to be, 0 dB. And then we want to look at our knobs to see if we're at the same point, 3 and 3. So that's telling us that our knobs are lined up, or I should say our VU meters are lined up equally, and our knobs are lined up equally. So that's telling us that those are configured properly. We don't need to calibrate those. We're good with that. And now if we look at our scope, we could see that we do have a signal on our scope. If you've got a digital scope, you could just simply push your auto button and it'll automatically set up your machine for you. If you have an analog scope, then you're going to have to go in and manually make the adjustments yourself. And the way you do that is with your time. See how it affects the screen, and then your volts per division. Alright, so as you see here on my screen, it looks like we only have one input, but actually we have two. If I move, you can see that brings it down. And so we have our two signals. Now when it was back up, that's exactly what we want to see. We want to see those two signals matched perfect like that. And so what that's telling us is both the left and right channel are outputting the same level of signal. Now when you're, forgot to mention this, when you're setting up your scope, you want to make sure that both channels are set to the same value. As you can see here, we're at 1 millisecond, 0.50 volts, 1 millisecond, 0.50 volts. So make sure yours is set the same, because we don't want to skew our reading. So that's good, very good. So now what we want to do is we want to hit record, or let the pause go. And I goofed that up, didn't I? So I need to hit both of these buttons. Oops. Hold on, I need two hands. Okay, sorry about that. I had technical difficulties. I had to work it out. So let's go ahead and carry on. We're going to hit the record. And we'll let that go for till about a 30 count. And you can see we're looking good still. Okay, so we let that record to, what is that, 30 feet there? Whatever, 30 inches per second. And let's go ahead and stop that. We'll go ahead and rewind. And you see there's our signal. Now, I do not have this connected to the amplifier, so we're not going to hear it. I don't have any speakers connected to the amplifier, so it wouldn't do us really any good. But we can carry on the test without actually needing to hear it. Hearing is good if you have the option, because with that it'll tell you if you've got any wobble or wow and flutter in your signal. So if you don't have a dedicated wow and flutter meter, whether physical or virtual, software, Audible works fine, as well as your O-scope and your AC meter. So now we got that recorded, and since we have this already set up for playback, we can go ahead and hit play on this. Our meter should be, well, not exactly at the 0 dB mark where we set it, so that could be a calibration that would be needed on the tape deck. And if we look on our scope, we can see that our pattern is off just a little bit. And you see how the signal bounces a little bit? Well, that's your wow and flutter. And resetting the machine gave me just a little bit bigger waveform, and so we all could see it a little better. Now, it is typical to have a little jitter, little wow and flutter. It's a mechanical device, and all mechanical devices are going to have that. There's so many things that causes wow and flutter, motor, belt, dried up lubrication, grease. Could even be, dirty AC mains coming into the machine. Now what we're seeing here, we're past the tone that we recorded, and we're looking at actually voice that was recorded onto the tape. That's probably going to be a radio station. So let's go ahead and stop that, rewind that, and while that's rewinding, let's grab one of our cables here, and we're going to hook it up to our AC meter. Okay, and we'll hit play on that. Okay, so we got a signal already, and we'll come up here and we look at our meter. And we could see a signal. So this is our right channel. And so if we pause the deck and then we remove our right channel, we grab our left channel. Now I really didn't pay attention where we were. We were probably around 7 or something like that. And go ahead and hit play. And so here's what the other channel looks like. And again, you can see a little bit of wobble in the meter. Again, that's your wow and flutter. So that's one way of testing. If you don't have an O-scope, you would just see where you're at on your AC meter and go from there. If we wanted to look at this on a frequency counter, we could do that. I rewound the tape. This is why I let it record up to 30, so we have a little bit of wiggle room. And so we walk right up to our frequency counter. And you can see on that channel, we're just slightly off frequency. Let me plug in the other channel. And we're reading the same. So what that's telling me there is our motor speed is just ever so slightly slow. However, this is really good. You know, I really wouldn't get too overly excited about that being exactly on 1000. You need to also understand that if you're using a tape that is worn, the tape is going to have most of the worn section at the beginning. The further on the tape goes, the more stable it may become, because it probably don't get used quite as often as the beginning did. So food for thought, and not to get too terribly excited if yours is a little skewed. Now we stop our tape and we will rewind that. And one other thing about your tape deck, just like your stereo, have everything turned to as neutral as possible. You want nothing to influence your signal. And I can't drive that home hard enough. All right, so let's go ahead and hit play. And confirm we have a signal. We grab our channel. Now I'm not going to do this for both channels. I'm just going to do one. I think we got the point of testing it on each channel individually. So now we're going to put this on a wow and flutter machine. Actually, let me stop this while we're doing that. And apologize, I need two hands to put my coupler on. So what I'm doing is I'm adapting a BNC to two banana jacks, because this device has two banana jacks for an input, and so does the next machine that we're going to look at. Alright, so I got that on, and this little tab right here on top, I can't use my finger to point to it, but it's the one on top. That represents ground. As you see, the other side does not have that tab. So so you need to know where ground is at on your machine, because both of these are marked in black. So we know ground is the bottom one. We'll put it in like so. And now we come back over here and we'll hit play. We got a signal up here. And now you need to set up your machine. I've got it set for flutter. I apologize, can't get the camera in there good enough. And then I need to turn down my sensitivity so we can get a reading. And so we're on the 0.3 scale. So we are getting around 0.2 for flutter. For wow, let's turn down our sensitive a little more. We're going to 0.01. So now we're at the bottom scale, and it's about 0.5. Now this information will be found in your service manual. Might also be able to find it in your owner's manual in the specs, and it'll tell you what your wow and flutter is supposed to be. I don't have either document for this machine, for this tape deck. So now we want to look at our frequency. And there we go. So with this machine, it agrees with the external frequency counter. Let me go ahead and rewind this because we are out of tone. And we'll hit play. Now while that's doing its thing, let's go ahead and go to the next machine. Next machine here is a spectrum analyzer, and an audio frequency spectrum analyzer. Covers 20 hertz to 20,000 hertz. On this one, it really doesn't matter where your negative goes. So I'm going to plug it in, and there's our signal. Really a good signal at that. And so you can see we're at 1,000 here, and that's what our audio looks like. So that looks really, really good, nice and strong. And as you see, we have no warble in that. We've got a good clean tone. Okay, so that's what we have there. We've recorded in a signal from our device into here and out. Now, as we saw, we had 998 kilohertz signal coming in. That's what the machine recorded at, but does that mean that this machine is calibrated? Not really. All you're doing is saying, hey, I was able to record a signal on my machine, and my machine did this. What needs to happen to confirm whether or not your machine is calibrated is you need to clean the heads, get rid of, and the pinch roller and all that good stuff, get rid of all contaminants in there. And that's where the isopropyl alcohol and the swabs come in. And then after that, you need to demagnetize. Now that's really, those steps are really above the scope of this video. But in case you've never done it, let's just do it quickly. You get, of course I can't, I need two hands to get my thing wet. Stand by. So you get alcohol on your cotton swab, and then you come down here and you clean this all up. I know the light's terrible. Clean it all up. Anywhere that metal, anywhere that the tape touches, you want to clean it up, because you're going to have all kinds of tape debris and dirt on there. And so you want your Q-tip as clean as possible. As you see, just the light scrubbing I did off the 2 points, that's what I got. You want to clean the rubber, clean everything in here. Let me do that, and I'll be right back. All right, so I got it all cleaned up, and this is what that looks like. So you want to make sure your Q-tip is as clean as possible. And once that happens, it should be nice and clean. Then the next step is to take your demagnetizer. This is a vintage demagnetizer. And then plug it in. And go about demagnetizing. Now you want to be very careful about touching metal parts with it. You really don't want to do that. You need to be mindful of that. And it'd be nice if you could do it in a nice sweeping circular motion would be great. I kind of like to hit all the stuff that the tape is going to be touching. Just walk it on out. So that's how you do that with that. I should put a rubber tip on this so I don't accidentally touch. Now, as I shown at the beginning of the video, I also have this demagnetizer. This is a vintage, got a couple of these actually, from the 80s. And this one's very, very easy to use. How easy? Just that easy. Reason why you want to clean out the tape deck, tape well, heads, demagnetize it, is really to confirm that yes, your deck really is calibrated. Because what we did here, we did it through the mechanics of this machine. That doesn't mean that this machine is really calibrated, because the motor could be off, it all could be off, and you're recording and playing back on the same machine. So with the let's say the motor's running slow, of course it's going to give you back the same response. It's the same machine. So you really need to have what's called a reference tape, and that's what these are, reference tapes. And what that means is these are recorded on, well, better equipment than this. Reference tapes are not cheap. They will cost you. If you got you know, like a TDK reference tape, or you know, a manufactured tape, they're going to cost you a lot of money, several hundred to several $1,000s. Next best thing is you go to eBay or your favorite auction house, and you find somebody who are selling these tapes, and these tapes run around $30 or so. And what you're looking for when you do that is somebody who knows what they're doing, who has better equipment than you got, better you know, tape deck, and serviced often, and it's on par, and it will produce a really good signal. And so that's what I did. I got these off the eBay. Like I said, I paid about $30 each or so. And you want to make sure your deck is clean and demagnetized before you put these in, because if not, to have a dirty deck, you're going to contaminate your reference tapes, and you want to keep these as clean as possible. And you notice that these have multiple frequencies. These frequencies do different things for your deck. The 1000 hertz calibrates the motor. The 3000 hertz will calibrate your azimuth. Now, we're not going to do the azimuth in this video. The azimuth is the head alignment, and that adjusts it back and forth. We're just going to do the tape speed. I mean, really, this is outside the scope of this video, but just trying to show you a little bit. So I'm satisfied that this deck is clean and as pure as it possibly could be. So I'll grab my tape and we'll put it in. Clear my marker, and now we hit play. Not yet. Where am I plugged into? I'm not plugged into anything. So let's go ahead and get our scope calibrated. I believe this is that channel. I mean, not calibrated, connected. And then we grab this one, plug it in here. At this moment, I'm not too concerned if I got the channels correct, because I just need to see a signal. Alright, so we got that all. Let's go ahead and hit play. Stand by, got to rewind the tape. Okay, tape is done. Let's go ahead and reset that. We'll hit play. It's playing. Now we'll look at, okay, so we have VU set, and then we also see our signal on screen. And now you can see all that wobble. Now, on the tape, we saw that it also had another number. Of course, this one don't have it. It was 0 dB. So, what we want to do with that is to see our meters, and we can see our meters are not in calibration. Exactly what we saw on our home recorded one. So, for that, we need to take an adjuster. Now you only do this if you know what you're doing. I don't take any responsibility if you muck up your machine. On my machine, it is these adjustments right here, and I know that because as you see it's marked. For my record is there. So take the alright, and now we look at the meter until it hits that first red. Back it down. And you want to do it to just enough. Okay, so that looks good. That's nice and solid. And now come to the other one. And we do the same thing to the other channel. There we go. And now, I just noticed something as I'm doing that. Watch the scope. Let me see if I can get them both in. Look at that. So, that does affect the output, not just the meter. Okay. So both of those are illuminated, and that's not exactly close. Push the button. Okay, and you can see it also looks like we have a little phasing issue. So I'm not going to stress about that. Alright, so our meter's there. Now we need to take one of these channels, walk it up to the frequency counter. And now you see we're pretty much spot on with that. a hair high. You know, I'm not going to worry about that, but if I were, the next step would be take you a non-metallic screwdriver. There we go, that's the one. Take your non-metallic screwdriver and go to the back of your motor of your tape deck and insert it in that hole. Now this is a flat head. And when you insert it into the hole, don't jam it in there. Go gentle, because it's very easy. You damage that, and then you'll be able to calibrate it from there. Again, I'm not going to. I'm close enough on mine. Now, there's a good possibility that your motor control is actually on the board. So that's where the schematic would come in handy, or look on your board to see if you got any silk screening like I did, to see if you do have the control there. And since we're here, there's the mechanics, there's our one belt. All right, so now we're going to take that from the O-scope, or from the frequency counter, and now we're going to put it on our wow and flutter machine. Give me just a second here to couple the cable. Okay, cable's coupled. We'll plug it in. And see, that one's just a hair high. Keep in mind, I have not calibrated this meter yet. And now we are looking at our wow and flutter. This is the sensitivity button. So you can see how wild the wow is on that. Let's see about the flutter. Okay, so now we'll walk this over here. And that looks pretty good. Okay, and then we walk it over to our, hold on, all tangled up. Walk it over to our power meter. Or not our power meter, but our voltmeter. Alright, so that's basically how you use all your test gear. How to couple things up. I think we've got everything. I think we went over everything. Now, I mentioned this tape right here earlier. I like this tape. It's not too bad to listen to. However, I find that this tape is really fantastic to test your wow and flutter. This is piano music, and you know pianos don't have any wow and flutter in them. No notes that stretch or twang or anything like that. It's a solid note. So with the piano, if you've got any discrepancies as such, you're going to hear it. And so I find that to be a very valuable tape to test with. Another tape that I test with is classic music. Pretty much the same thing. If there's a lot of heavy wow and flutter, you'll hear it in these kind of musics, but primarily the piano music. And besides that, everybody should have some nice honky-tonk music at home. It's good music right there. Alrighty, I think that's it for this video. I think we've covered everything, all the machinery from simple to basic. O-scope really is going to be your best bet on all of this. It don't have to be an expensive O-scope, and it don't have to have all the bells and whistles. It just has to work. And I understand about being on a budget. If you troll eBay and put in your budget, set up a savings search, you'll eventually find one. You can find vintage O-scopes for 10 bucks, 20 bucks plus shipping. Sometimes you might even get lucky and 30 bucks shipped. So it all depends on what you're after and what you're willing to settle for. If you're just starting out, start out with something basic and simple and move your way up. That's exactly what I did, and that's where I'm at now. So that's about it. Again, let me give you that other YouTube channel that I recommended in the first channel, or in the first video. It's Old School. Now he works a lot with audio equipment, a lot more than I do, and he's really good at what he does. So you could definitely learn from him, as I did. Anyway, the link for his channel will be below. I forgot to do one thing. After we calibrated the meters, we now want to see how our recorded tape worked. So let's go ahead and put that in. Oops. Guess it wouldn't hurt if I start aiming the camera where you could see. So we got our test tape in there. Now we're looking for those meters to be on the red, and that's exactly where we're at, on the red. Cool. So those meters are now calibrated. And those numbers on the tape I was telling you about, wrong tape, right here. So you would want to, if that was, let's see. So our 1 kilohertz at 0 dB. So that's how you'd read your meter, is you want to make sure that you're at 0 dB, or in the case of the 7 kilohertz at negative 10 dB, then you want to look for your negative 10 dB. And that's how you read your meter. That's how you confirm your tape is outputting, and that's how you confirm everything is calibrated correctly. At least at a non-laboratory environment such as what you and I have. Okay, that will do it now for this video. Again, thanks for watching. Do appreciate it, and we will catch you in the next video. Thanks again for watching. See ya.